Bytes and strings. In Solidity, both bytes and strings are used to represent a sequence of data, but they have some differences. Byte is a type that represents a sequence of bytes that can be a fixed or a variable size. It is not a value type and is stored as a reference to a location in memory rather than as a single value. String, on the other hand, is a type that represents a sequence of characters that are encoded in UTF-8 format. Like bytes, a string can also be of a fixed or variable size, and is not a value type. There is no easy way to manipulate strings when it comes to Solidity. Solidity is simply not built for that, and made more for computations and working with numbers. That being said, although storing strings can be a bit expensive, you can manipulate it to some degree, like concatenating and slicing strings, by using bytes and converting them into strings and vice versa. Let's start off by declaring a string variable. We can do that by writing the keyword string, followed by a variable name. In my case, I'm going to actually call this name A, and I'm going to equal this to my actual name Daniel. This name A variable now represents a string, which is a sequence of characters encoded in UTF-8 format, Daniel. But we can store the same value as a bytes array. We can do that by writing bytes, and then I'm going to say this is my name B, and this is also equal to Daniel. These two variables look like they are storing the exact same value, but under the hood it's not. If we go ahead and make this public because I want to deploy the contract and see the actual values, let's make them public, click on deploy, and let's quickly read value A. So name A, we can see is Daniel in a UTF-8 format. But if we click on name B, we don't see Daniel and we see these weird characters. This is indeed Daniel, the value, but just displayed in bytes. And this is also why using bytes is more gas efficient than strings. Computers just simply work better with bytes. And to make it even more gas efficient, bytes can have fixed arrays. So basically we can say bytes 1. But if this is the case, we can see that Daniel will be too big. We can probably only store one character. But if we want to store larger values, I recommend using bytes 32. You can store a large amount of string data basically in bytes 32. For now, let me change this back to bytes and show you an easy conversion. If we have a variable that is string, and we're going to make this public as well, this time this is name C, and instead of writing a string in here, I'm actually going to say this is going to be name B. Now there is going to be an error and it's going to tell us that, it cannot be used like that because this is bytes and you are trying to store it as a string. Well, that's not a problem because the only thing that we need to do is cast these bytes into string, like so. And once we have done this, the bytes are converted into string, which we can then store in name C. And we can do the exact same with bytes. So if we have bytes here, and we say that our bytes, this is going to be D, needs to be the name A, we can convert this into bytes. So if we deploy and we go and open the new contract, we can see all the values and how conversion takes place between these types. Lastly, let me show you how it would work if we want to do some string manipulation. We're going to start by writing a function and call it concatenate and return string. Now this function we're going to make public and it needs to return to us a string. So we can specify that it's going to return string, but we cannot just use that. We need to say that this string is going to be memory allocation that it's going to use. Now this memory allocation, you'll see it pop up in Solidity. Remember our diagram. Whenever a function or process is kicked off in a contract, for the duration of this transaction, it has access to this memory allocation. But we'll touch more on this in a later section. For now, we need to create a new variable, and this variable is going to be bytes. I'm going to call this my data, and For this, I'm also going to have to say this is bytes memory. Now, what is this data variable going to be? Well, we need to concatenate two strings or a string and bytes. So a function for that we can use is called abi.encode packed, like so. Now, this is a very special function. We can give this function some values and then it will return to us bytes. But we can also concatenate a few values. So what we want to do is take this variable a, put it there, put a comma, and then add an empty string with a space, and then type in name b, for example. Let's not forget our comma over here. And now this function will concatenate a and name b, and then give us back the data in bytes. So we need to return a string from this function. So what we need to do here at the bottom is say return, and then we need to cast these bytes as string. So we're going to say give us back string from this data. And over here we can just simply make this function view, which we'll touch on later as well. For now, let's go ahead and deploy and call our function. And we should see the string and the bytes being concatenated. Let's clear our deployed contracts and then go ahead and deploy the new contract. Okay, and here is our function. So if we click on this, we will see Daniel space Daniel was successfully concatenated. So this is how string manipulation would work in Solidity. Before we move on, and I know we are not at functions yet, I would like to illustrate something over here. Typing the name a and b in this function, just because they are variables here, is known as hard coding. Sometimes that's not a good idea, especially if you want to reuse this function. So instead what we could do is we can say this will take in some kind of string, and we have to say this is memory allocation, and we're going to say that this is name a, and we're also going to say it's going to take in another string, memory name b. And then let's get rid of these variables. And in fact, instead of name a, I'm just simply going to make this a and this one b. It's way shorter and is more generic. And then I'm going to swap these out too to say a and b. And instead of view, we can see that Solidity recommends we make it pure. And that is because we have nothing to do with any state variables. So this function doesn't have anything to do with the storage of this contract. It can live on its own, and all it's going to do is take some parameters and concatenate them. Let's go ahead and deploy the contract, and now here's our function. We can see that it takes in a string a and a string b. So now I can write Daniel, comma, Buerta. The parameters are split by commas, and when I execute this, I can see my full name concatenated. This function ran, made it into bytes, and returned a string again. Now, if you don't fully understand functions and what we did here just yet, don't worry. Like I said, we're going to cover it, but it's always important when we see these opportunities to maybe learn something on how we can improve the code. As long as you know that strings exist in Solidity, and you can also use bytes. Bytes is the preferred one to use when working and manipulating strings, and it's also cheaper on gas.